So in this video we're going to take a look at question number 3 from 2017 Maths Higher Level Paper 2. In question 3 you have a triangle where the coordinates of A and C are 0 and 6 and 4 and 2. Point G is the centroid of the triangle and segment AG intersects BC at point P. So if we extended this line a little bit further, this point here would be point P. And segment AG and segment GP are related to each other in a ratio of 2 to 1. So what this tells me that if we're going from A to G for the X and then from G to P, the transformation will use twice as many units for X coordinates and twice as many units for Y coordinates as the transformation from G to P. So X and Y. So when we're moving from A to G, we're using plus 2 over 3x, and we're using minus 14 over 3 Y coordinates, Y units rather. So then when we're moving from G to P, we're going to use half of that, so then that's plus a third, and then minus 7 over 3. So then coordinates of P will be 2/3 plus 1/3, which is equal to 1, and 4/3 minus 7/3, which is equal to minus 3/3, which is equal to minus 1. That's coordinates of P, 1 minus 1. Coordinates of B. To find coordinates of B, I recognize that the point P is midpoint between B and C. So P x y is the same as xb plus 4 all over 2 and yb rather plus 2 all over 2. So I have two small equations, x plus 4 over 2 equals to 1, and y rather plus 2 equals to minus 1. So from the first equation I'm going to get that x is equal to minus 2, and from the second equation I'm going to get that y equals to minus 4. So coordinates of point B are minus 2, minus 4. And now we have to prove that the point C, which is this point here, is the orthocenter. Orthocenter means that this point is a cross-section of lines that are perpendicular to the base and contain an opposite vertex, which then tells me that if point C is an orthocenter, then it's an intersection of line AC and BC. So what I need to do is I need to prove that, I need to show that line AC and BC are perpendicular, and I also need to show that the intersection of line AC and BC is point C with coordinates of 2 and 4. So first step, show slope AC is equal to 6 minus 2 divided by 0 minus 4, so that is minus 1. Then slope BC is equal to minus 4 minus 2 all over minus 2 minus 4, and that's 1. So MAB times MAC rather times MBC slopes when multiplied give me minus 1, which tells me that they are perpendicular. So that's the first point. Then I need to find the equation of each line. So line AB, using point 0, 6, y minus 6 equals to minus x. So from here I get that x plus y minus 6 equals to 0. And then for line BC, I'm using so I'm using coordinates of point B, which is y plus 4 equals to positive x, x plus 2. So if I transform, I'm going to get the equation of this line equal to x minus y and minus